First thing I'm going to do is loudly open this can of LaCroix. Good. Now we can begin the talk. My name is Abe Haskins. I'm a developer programs engineer here on the Firebase team at Google. I sit about 4 floors below where we are right now. And I'll be honest, I did not hear all of those lightning talks, but I heard a lot of very fancy credentials from that lady, whose name I didn't hear. So I thought, not to be outdone, I need to tell you about my credentials, just so you know that you can respect me and appreciate all the advice I'm about to throw at you. So, I failed 8th grade algebra. That was a low point. Then I eventually went and got a business degree and wanted to be a software engineer. And Firebase said, we have no confidence that you can do anything at all. So they gave me 2 weeks. And they said, in 2 weeks, if you're still doing anything okay, you can come join us full time. That was 5 years ago. So I just hope they didn't notice that I'm still here. Because eventually, they're going to catch on and be like, this guy doesn't know algebra. So today, I'm here to talk to you about this philosophy I've ideated, this whole thing I've created that relates to software development, about how to build things. Specifically, this talk was originally about serverless technologies, building with cloud functions, thinking about what changes in building great code when you're dealing with cloud functions and serverless. But it's really kind of a general, thing to think about as you're building applications, building web apps, and the like. So one thing that is always the same, regardless of what you're building, is you want to build confidently. It doesn't really matter, like I said, what you're building, but you want to have the confidence in every step of the way. So that means not only confidence that the code you're writing is doing what you want it to do, but you want to be confident that when you're running it in production, it's running well. You want to know if something goes down. You want to be confident that you're going to hear about it, not from your user, preferably before anything actually gets to user-facing. So this is all about confidence. And serverless is about confidence, but everything else is also about confidence. This is how we build software. We want to know what's going on. And I think as engineers, as most of us are, we often forget all about the parts that aren't about writing great code, because great code is good, but it's not the entire problem that we have to deal with. So there's a bunch of elements to this that I've put together that I think kind of summarize things to be thinking about. And as I go through this, it's going to be really, really fast. We have like 60 slides to get through. And my goal is now for you to say, oh, I remembered every one of those 60 slides. But I'm hoping you walk away and think, oh, yeah, maybe that's a way I can be a little bit more confident in what I'm building. So we'll talk a little bit about building great code. We'll talk a little bit about how to test. I know everyone knows tests are great, but we'll talk about it a little bit. We're going to talk about deployment and rollback. We're going to talk about how to deal with configuration, different environments, production, staging, stuff like that. We're going to talk about how to monitor your application once it's shipped into production. And we're going to talk a bit about pricing, how to run an application in the real world without going broke. Because eventually they're going to realize you don't know algebra, and then you're going to need to have it be very cheap to run. Otherwise, you're going to have to shut it down. So all these words I have here, put together into this lovely acronym, Cedar Camp. And that is code, testing, deployment, rollback, config, environment, monitor, pricing. As you can see, it's very catchy, which is why I had to go back to remember what they all were. But if you want to make this easier, you can just call it what I call it, which is Cedar Camp. And I don't actually know if that helps anything, but now I get the little trees in the corner, and that cheers me up. So once again, here's what we're going to cover. Let's just get into it. The C in Cedar Camp, code. Most of us have looked at code at some point. I know I have, at least once. And code is one of those things where when you're writing it, it's very exciting and it's very fun, but a lot of times we're not really thinking about the long-term implications of what we're writing. As you get more mature in your development philosophies, you start thinking about maintainability, scalability, what it's like for the next people to maintain what you're writing. And if you're in this room, you're probably thinking about this while writing JavaScript. JavaScript is a language. Love it or hate it. If you love it, you're objectively wrong. And if you hate it, you're very enlightened, like me. So I want to talk briefly about how to make JavaScript better. And if you look at this snippet of code, all throughout this presentation, I'm going to talk about Firebase. Obviously, I'm biased. I work for Firebase. But ignoring that, I'm just using it kind of as a background here, and as an example of a serverless environment, as an example of an SDK. And in this case, I'm using it as an example of an SDK that is easy to make mistakes in. This snippet has a bunch of issues, and you might not catch it if you're just trying to read this. If your static analysis skills weren't incredible, you probably can't figure out what's wrong with this very quickly. And there's a few things. And these all come from the main issue that JavaScript is just really not good. It has, for example, a missing return. We never actually return anything from this function that's called isUserPrivileged. It's missing an invocation. Firebase database is actually a method you're supposed to call. And it's missing val, that's string. It's supposed to be value spelled out. So to know this, you'd have to not only be a good JavaScript developer, familiar with asynchronous control flow, catch all of that, also know that val is not value, and it's very difficult. So even I've written more than one app using Firebase. I would not be able to catch this. So what is our solution to this? The solution is not to use JavaScript long term. But short term, the solution is TypeScript. If you are not familiar with TypeScript, well, let me take a step back. There are two types of people. Those who love TypeScript and those who are objectively wrong. And I want to talk to you in a way that compels you to be objectively correct. So all of these mistakes here would be caught at compile time with TypeScript. Now, if you're a JavaScript developer like I was brought up, well, first I was brought up writing a language called Program. No one writes Program anymore. And then Python. And then JavaScript. So I wrote always dynamic languages. You're probably thinking, well, JavaScript's fast. It doesn't need strong typing. It doesn't need these things because it speeds up my development. But when you're making mistakes like this, it simply doesn't. It comes back to bite you. You have to iterate more. And if your iteration isn't fast enough, you just double down on slowness, and it makes your code worse. So once you introduce TypeScript and its ability to know very advanced things about the SDKs and the libraries you're using, it becomes really easy to catch things and convert it into code that not only reads better, but is actually correct. And it's actually correct regardless of if you wrote it or the person down the row wrote it. Because I don't know about you, but I don't trust anyone I work with because I'm the smartest one in the row. So I would know that they should do it this way. I'm kidding. I'm definitely not the smartest person at Firebase. Objectively false. A lot of things are objective in this talk. That is also objectively false. So switching over to TypeScript, we get a bunch of advantages. The big advantage first, async, modern JavaScript stuff, that's fine. Async await, that's great. Typing's down to the string level. So TypeScript will tell you if that once method can take the string value. It will tell you if that is okay. If you type val, it's going to say, no. That's not a thing we do here. So that alone is huge. It's hugely valuable. And then it'll tell you, hey, if I set up this function, if I used it somewhere else, and I expected isUserPrivileged to return a Boolean, like you might expect it would, and it doesn't return a Boolean here, TypeScript's smart enough to tell you it should return a Boolean. Or at least in this case, a promise that resolves to a Boolean. It's smart enough to know all this. So my point is, by taking your life away from JavaScript, relying on the type system, relying on TypeScript, it's going to save you a ridiculous amount of time. One of the other ways, TypeScript, the entire first part of this talk is just why you should use TypeScript. The second part about why you should use TypeScript is auto-completion. And this, again, if you are a genius, if you are the smartest person in the world who passed 8th grade algebra, you will be able to know every method that you will use in your program. But I can't do that. But TypeScript allows us to have really coherent, really intelligent, world-class auto-completion. And this is the type of stuff that generally dynamic programming engineers dream of. We don't get this. We don't actually get to know what our different types are returning. We can guess. Like Sublime is kind of good at guessing what you're using. It's like, oh, you mentioned the word caterpillar elsewhere. You might want to type it here. But it's not good auto-completion because it's hard to parse languages like JavaScript, which is why they're objectively really not good. So you can see the trend here. This typing system, the strength that TypeScript gives you will objectively make your code better. But it won't just make your code better. It'll make the code you're relying on better. And this, I will concede, this is the weakest point in my TypeScript spiel. Because every time you pull in a library with JavaScript, and you probably learned this if you've been engineering for a few years, you pull in a dependency, today it might be great, and in like 6 months, the maintainer is going to be like a little bored. He'll accept a pull request once in a while, but it's a little out of date, but it's fine. 3 years down the road, and that jQuery dependency that you're still relying on is going to be unmaintained. You're going to go look on GitHub, and it'll be like, last commit was 3 years ago, and you're going to be like, oh, that's not good. And you're going to have these issues where if they do accept something, the maintainer of that package that you're depending on will have changed. Like, they'll have different ideas and different philosophies and probably write code in different ways. They might change method signatures without alerting you. They're going to change a bunch of stuff under your nose that makes relying on third parties even more difficult than it already is. But, of course, as you might suspect, TypeScript helps with this. So let me give you an example, real world. If you're a Node.js developer, you've probably used one or both of these packages. As a side note, if you search for colors in NPM, it comes up with 3,600 packages. How you would possibly know that these two are the two anybody uses is beyond me. But assume you've narrowed it down. You've been like, those other 3,600 libraries are trash. I'm here for either colors or chalk. How do you know which one to choose? You could look and you could say, well, which one was committed to most recently? Which one has the most traffic? And I'm pretty sure colors has the most traffic, but I'm not sure. It might be chalk. I honestly can't remember. But there's really no way for you to tell which one of these is modern, who is building in a way that's going to be safe for me to rely on them. If we pull open these projects and we actually look at the package JSON, we're going to get a hint about who is maintaining these, how they're looking at development, and how serious they are about maintaining it. Because if you look at this library, colors, there ain't no TypeScript in there. And as I've said, if you're using TypeScript, it's going to be objectively better. So if we look at chalk, we'll see these references to DTS files, and all this is saying, really, is that the maintainer of this library cares enough to make a commitment to you, the person depending on this package, that their interface to their library is going to stay the same. And at least if they change it, it's going to go and change in a way that when you try to compile your code, it's going to fail. They're not going to change a method. They're not going to change what the arguments are, and then have you discover that when your user tries to click a button that you implemented 3 years ago and it doesn't work. So this is kind of the magic of TypeScript. This library isn't even written in TypeScript. They just added this typing file and they make sure it stays in line. But that benefit of knowing that what they're working on is going to be held to the standard is a huge, huge benefit. So most of the time when I'm working in JavaScript now, I'll actually work in TypeScript, and I'll only work in languages or with libraries that have typings that are either written natively in TypeScript or have these DTS files specified. And 95% of the time, these are more recent, better maintained, and just generally higher quality libraries than ones written in native JavaScript. And part of the reason is because JavaScript is just hard to maintain. You can do it if you're really smart and you passed 8th grade algebra, but if you're like me, it's very, very difficult. More info about this, if you're generally curious about TypeScript, I'm going to throw up a bunch of links like this after each of my letters. You can either take a picture of it here, or at the end, I'll have a big page of all the links, so you can go check it out then. But let's move on to testing. If you thought I was passionate about typing, get ready to hear me yell about testing. So step 1 of testing, write some tests. Because if you don't write tests, there's no way you can test anything. And if you write 1 test, that's pretty good. If you write 1,000 tests, that's not 1,000 times better. It's probably like 50 times better. I don't know. Math is hard, algebra. So all I know is that every time I've written a test, written a little file that actually runs my code, some unit test, even a smoke test, something, it has made my life better. It's made my iteration quicker because instead of having to switch to the browser, click, all right, I hit this button, and then I hit this checkbox, and then I see if the UI updates correctly. That is always slower than having a headless browser go and do it. Now, obviously, there's like an ROI here where if it takes you 6 months to put testing into something that you already have like manual QA people to do, it might not be worth your time. But in terms of building things new, write some tests. Just write some tests, please, please. Step 2, people don't like doing things that aren't easy, generally. So what you got to do is make it easy on yourself to write tests and make it easy for your coworkers to write tests. So let me give you an example. Here is a function I wrote, send to room. It deals with Firebase cloud messaging. It basically goes and pulls out Out of the database, it says, all right, whenever somebody sends a message, go and push notifications to every user who cares about this message. This is a big blob. In this case, we're using the Firebase Functions SDK directly. So this part in the beginning where we're like functions.firestore, that is all specific to the Firebase Functions environment, which means in order to test this code well, you have to deploy it to the actual running Firebase Functions environment. And if you are like me, you probably noticed that's pretty slow sometimes. And it is a huge pain when you're trying to iterate. So we can refactor this, and we can think through and say, all right, we know we're going to want to test this code. We know we're going to want to check and be like, all right, I'll fake a message, and we'll see if it actually sends all the way through. So here's a different way to structure this exact same code. The first thing we changed is the top-level namespace. Now, this is something specific to Firebase Functions, but instead of exposing individual methods to functions, you can expose a namespace, you can expose an object that has fields on it that are individual methods. So in this case, I've wrapped everything here under FCM. And that way, I can now break it out into two different types of triggers. One that's a manual trigger. It's an HTTPS endpoint, which in other words is just like localhost 8080. So I can go and I can manually call that, and I can test this locally. The other one is an automatic trigger, and this is the one that actually comes from the the Cloud Firestore trigger. When you write to the database, it does this thing. And I keep this logic as simple as possible, because all it's going to do is go do the function-specific logic, pull out like the room ID, who it's to, what the text is, and then it's going to call out to a separate method, send a room, and that's going to be where we actually do all the logic. And now I can go, I can test that send to room method separately. I can call that manual endpoint separately, and we just have this nice clean separation, not to mention the namespacing that comes with all of this. So just by doing a little bit of thinking ahead about how can I hook into this, how can I do this without actually going through my entire UI, you give yourself a huge benefit. Part 3 of writing tests. After you've written your tests, which you did because you made it easy, you need to run your tests. Now, when do you run your tests? That's a great question. Some people use automatic tools that run tests every time they save a file. That can be fine. Preferably, I like to run my tests every time I deploy and every time I commit my code. So here's an example of just a pre-deploy hook for Firebase Cloud Functions, which basically says you cannot deploy unless the test pass and everything's been built successfully. And this isn't going to stop me if I really want to deploy a broken piece of code. I can do it by hand, but it will make sure that my test suite runs and passes before I ship anything to staging or production. And just doing little habits like this, where instead of being like, all right, we're going to trust everyone else to run the tests, put it in your chain. So as you're going and as you're building, when you go to commit something, you think, okay, I have to go through these steps before I allow this to get anywhere near production. So not only am I writing tests, I'm writing tests more because they're easy, but I'm being forced to actually run them and keep them up to date as things change. But that's only part of this problem, right? You can't build perfect code. It doesn't happen. You can have a million tests, and you will have wasted a bunch of time writing a million tests, but you could do it. But it doesn't matter, because you can always ship something broken to production. So we're going to talk about deployments and rollbacks. If you are like me, you are very forgetful. And if you are like me, you use a lot of random technology in your side projects, and perhaps at work. Generally, people kind of stick to one thing in their day job, but I have deployed things on Kubernetes. I have deployed things on Cloud Functions and AWS and Lambda and Heroku, and I don't know if it's stdlib or standard lib. Those folks who are just here, code.xyz is really cool. I've deployed things on there. All of these require different ways of actually deploying your code. And in the best case, it's one call, like one CLI call, where you say, like, okay, like push this to production somehow. It might be copying to an SFTP endpoint. It might be redeploying to Heroku. But most of the time, there's at least two steps involved. You're going to build something, you're going to webpack it up, going to bundle everything up, and then you're going to ship it. And without fail, I have always forgotten how the heck to do that. Because as soon as you get more than two commands involved, as soon as you don't write it down, which I never do, you're going to forget how to deploy things. And it's not a big deal, like I said, if it's in your day job. Like generally, these things are well documented and you'll remember. But If you're moving around a lot, this is really, really critical. So what do? How do you make it easy on yourself to get your code into production so that 6 months from now, when your side project has some error and you fix it, and then you're like, wait, how do I deploy this? How do I get this installed again? What CLI do I need? Do I need the G-Cloud CLI? Do I need Firebase tools? What do? You use any continuous integration tool. I don't care which one. I have a personal bias towards Semaphore, but literally any continuous integration tool will do here. And the gist of these tools, if you're not familiar with them, in their simplest use case, is you write a little script and you say, here are the steps to get this built, get it shipped, and then you hand that over to these and say, whenever I commit or whenever I push this button, do a deploy from my GitHub repo. So you're not deploying directly from your machine anymore. You're saying, if I commit to GitHub to the production branch, bundle that up and ship it out. And because what we already did, we made sure that our functions and our tests run and succeed before we allow anything to get deployed, that'll also run our tests, and it'll make sure everything is successful as it gets sent up to the internet. So as a quick example of this, I run this website, jpeg.cool. It's a very cool website about JPEGs. And all this website is if you go to jpeg.cool/hello.jpg, it'll search the internet and it will return you a picture of the word hello. It'll find something related to hello. Or go to jpeg.cool/Abe Haskins. You'll probably find a picture of me. But it's very, very simple website, very straightforward. But inevitably, it's slightly hard to deploy. It's a few steps. So what I went and did was set up Semaphore CI. I wrote down a little script. And now if you asked me how to deploy jpeg.cool, I would not remember. But what I would remember is if I go to GitHub and I edit something, if I edit any file, it'll automatically deploy. And you can see this timeline here below. You can see I deployed manually. Before that, I deployed because I added reporting, chat message, whatever that was. And before that, you see it said passed because that's it's running my tests to make sure that that change that I quickly made 6 months after I last touched the code base succeeded and everything went well. So this is what my actual setup looks like. It's pretty straightforward. Yarn install some stuff, build it, but this is just written down in Semaphore. Not something I have to remember, and it's a few steps, but it's enough that I'm not going to remember. And here's my GitHub commit log. So as you can see, I'm committing random stuff, and it's going over here and going well. But imagine, like I said, you make a mistake. This is the second huge benefit of continuous integration and continuous deployment. When you mess up, which you will, not because I don't like you, but because you will, when you mess up, you can go and you can hit this deploy manually button. It's right way over there. Right here. This deploy manually button lets you go back to any commit you've ever made and say, now deploy this version. Now this obviously isn't perfect because, for example, a database schema could change between commits, and there are issues with that, which is why you should really tag releases as you do them. But this allows you to go back in time. So if I make a mistake, I ship something that is fundamentally broken, I can go back and I can deploy manually. Because what I don't remember to do, or I don't remember how to do, is how to get to the past, go back 2 commits and then redeploy my stuff and stash what I was already doing. I have no idea. But by using a continuous integration tool, I now have a one-click button that says undo that mistake and get me back to where I was. This is huge. This is so valuable. And it takes minutes to set this up. It is so simple because if you set it up when you're working on the project the first time, you're not going to have any trouble remembering what commands to do. It won't be hard to set up. But it will be so, so good in a few months. More about setting up Firebase specifically with Semaphore. I wrote a blog post about it on the Semaphore blog. You can read it if you want or don't. Moving on, config and environments. Deploying is great. Deploying to production is great. What's better than deploying to production? Deploying to staging, or deploying to testing, or deploying anywhere. Having continuous deployment is great. But configurations and environments are still a hard problem. So you can imagine, I commit to JPEG cool. I make a change. And for example, I want to test that change. I need my staging environment. My staging environment needs to be separate in every sense from my production environment. Different database, different credentials, different API keys. It all needs to be separate. So how can we handle that? What's that really look like? Because if we check those things into Git, they're just going to be picked up by our continuous deployment and rolled out. So if I ship it to production or I ship it to staging, it's not going to matter. It's going to connect to the same database. So we can talk about a bit about using environmental initialization. I know this is a pretty Firebase-specific trick, but this general idea is really interesting, where instead of ever putting a project ID or a hard-coded, this is the project I'm talking to, with Firebase, you can pull in this magical init.js script. And this script will automatically initialize Firebase for whatever project this is currently running as. So if you're using the Firebase command line tool, you run Firebase serve, it'll automatically initialize to the project you're using. If you deploy it to Firebase hosting, on Firebase hosting for project A, it will automatically initialize for that. If you deploy it to project A staging, it'll automatically initialize to that. So we don't have anything hard-coded in our project that actually ties our code to our environment. And this is great for two reasons. One is that now you have this amazing ability to deploy the exact same code to two environments without any changes. This keeps your continuous integration simple, and it makes sure that when it's in the environment, there's no chance any developer is going to write to the production database when they're testing. But it comes with another big advantage, is that as soon as you start doing anything like this, you start storing any initialization in your environment, you can store arbitrary data in your environment. So here's an example of pulling in just some random initialization data. Again, this is Firebase functions, but this general idea still applies, where instead of having a hard-coded client ID, a hard-coded bearer token, I'm using this magical functions.config thing. As just part of Firebase that says I can store anything in the environment, any string, any key, any secret. It'll be stored securely, and I'll only be able to read it when I go and deploy this to that environment. So instead of having database keys in a config file, a JSON file in our repo, we store them in the environment, and it's safer, quicker, and generally more secure. It's also very easy to back these up and say, all right, I want to clone these to staging, and then I'll modify the important ones, but I'll keep my Bing API key the same, whatever APIs you're using, if they don't matter. So it's very straightforward to keep your environmental initialization specific to the area you're working in. And that just makes this clean, because then once you have that, once your code is agnostic to the environment it is running in, using continuous deployment to throw it up into staging or testing, it doesn't matter. It's the exact same code, but the environment is changing. Again, sorry, so much Firebase-specific stuff. The last part is if you're doing this with Firebase and you want multiple environments in Firebase, use multiple projects. This is mostly an aside, but people ask us all the time, I want to have a testing deploy of my cloud functions. How should I do it? The answer is you should have another project, because everything needs to be separate to do this, and it costs you exactly the same to do testing on another project as it would to do testing on your main project. So there's no reason not to have multiple projects. More info about this, specifically about web configuration and Firebase multi-environment variables. Again, these will all be at the end. M, monitoring. So let's say I'm a developer, I've written my code, good. I use TypeScript, good. Deployed it, good. In the right environment, good. But I still need to keep an eye on what's happening. This is where the monitoring comes in. And this is generally also where everybody stops. Most people in the world, I think we're an exceptional group of developers here. I think San Francisco people are generally exceptional developers. But in most cases, people stop at this M. They stop monitoring their applications. And they do it because it's hard. It adds overhead to the code base. You end up thinking like, oh, if I put in an SDK to monitor what's happening, I'm going to get slowdown in production, and I monitor it with the slowdown, but that's great, but that's not really indicative of what it does without the SDK to monitor it in. It's just very silly. So I'm going to talk real quick about how we can monitor our applications with the least amount of effort to be very confident that we know what is going on in our app. So whenever we talk about monitoring as it relates to Google Cloud or Firebase or basically anything, we're going to be talking about Stackdriver. Stackdriver is a really exceptional, I believe it is partially open source tool for monitoring your application. I'm not going to dive into everything that Stackdriver can do. It is a huge, powerful application. But I'm just going to talk about the things I find very easy and quick to put into my apps so I know what's going on. So step one, if you are like me, you still rely on console.log way more than you should. That's fine in a lot of situations. It's very consistent. You can always print stuff out. So if you're really good at debugging via printing, that's fine. But we can do a lot more than just console logging. So in Firebase, in Google Cloud Functions, in Compute Engine, in any of these environments that we offer, if you log something out, it's really easy to get it into Stackdriver logging. Now, this is part of the Google Cloud Console that you can go check out if you already have a Google Cloud project, as I'm sure many of you do, because you're in the Google office and we don't let you come in without one. You can easily go and see all these logs for not only your projects, but internal stuff like what our applications are doing on your behalf. So for example, if you're running a Google Container Engine, Kubernetes Engine application, you'll be able to see logs from the processes that are actually maintaining your cluster. The part we run for free for you, we keep an eye on. So in this case, I'm running this application, JPEG cool still, and you can see this is just a normal console.log in my code. There's nothing special here. I don't have a snippet of the code, but there's absolutely nothing different here than logging out into the shell in Node, just console.log your heart out. But we can see we get a bunch of information. So for example, way over here, you can see where it says request cool, fulfill cool, request cool. That's the method that's printing out this information. We get this crazy unique ID next to it. That's the invocation ID. And then after that, we get the actual log of what I logged out. So it's different data, different types of traces. But the really cool thing is, if you have a traditional log, if you have that console.log in your application, and you just spit everything into a text file, and you just do traditional Apache Nginx logs, where it's just like gigantic files separated by arbitrary points of time, they're pretty hard to debug because you end up with all these asynchronous calls that are logging things at different times, and they get all out of order, and it's pretty hard to follow through an individual invocation. But of course, I wouldn't bring this up if we didn't have a solution. So if you click on one of these invocation IDs, one of those crazy unique IDs, it'll show you the lifetime of that specific invocation. So here's one of my cloud functions. As you can see, it started, function executed at 9:02. It ran this user code /Genki, which is part of the backend, and then it goes, prints this to std and then closes, and then here's the actual body it sent back. The phrase was crickets, and it sent back this URL of a picture of crickets. So we've already enhanced console.log. We haven't changed our code at all, but we get way more insight into what's happening. And as you can see, this filter up top, it's not really SQL-y, but we get all sorts of filters. We can arbitrarily shift things and say, all right, what do I want to look at? Do I want to look at US Central, or do I want to look at all my recent requests from Beijing that happen to be slow? Beijing's a bad example, but other countries that like Google more. Those are all easy to do, easy filters to do here, because we're using Stackdriver logging instead of a text file. But that's just the beginning. That's great, obviously, and it does really honestly help a lot, but we can move beyond console.log to the point where we can do things like this. Stackdriver error reporting, also no code change. Nothing about your cloud function will change to get this. You just have to go and turn it on in your Google Cloud Console. And now every time you get an error, somehow everything got past your testing, got past your your staging environment. If your code throws an error, it will show up right here. It'll tell you how often it happened. It'll tell you when it was last seen, what function triggered it, all of this really useful information. So now we're not even relying on console.logs anymore. There's no console log in this picture. It's just keeping an eye on it with very, very little overhead and saying something bad happened, let me know about it. So if we click into one of these, we get all sorts of nice charts. Below you can see the stack trace, which is exactly what you would get in Node when an error occurred. And we get all this information about muting it. We can tie it to a bug in our Jira or Frog bugs or whatever the kids are using for tracking. And you can, of course, click purge.js. That's the file where this error exists. You can click right into your source code. And it's an incredibly powerful and rich experience. No code changes. Just going in and turning on Stackdriver. But this is all reactive, right? This is something went wrong, and I need insight into what's happening. I need to go and this error happened. What if we want to just keep an eye on things? So let me give you an example. With JPEG Cool, I have a cron job that runs about once every day. Because every time I do a talk and I mention JPEG Cool, a bunch of people search really weird stuff on that site. And it fills up my cache, and it has a ton of data in there, and it'll return GIFs and stuff, and GIFs get really big. So if you search the right one, it's 120 megabytes, and I have it's sitting there forever unless I clean it out. So that's what this does. This cron job is set up to run every day and just look and say, when was the last time anybody accessed this? And it's basically just a simple cache implementation, throws out anything that isn't, hasn't been accessed in the last 7 days. So this is part of the Google Cloud Console. I know it looks a lot different than this. It's much darker, much cooler looking. But there's a button in the Google Cloud Console that's just say, hey, let me go to Stack Driver Monitoring. Let me check out my metrics. And in this metrics dropdown, we have a million things. You have App Engine stats, you have cloud storage stats, you have your stats for your Redis instance and your cloud functions, and a whole bunch of options to slice and dice those. So in this case, I'm looking at a very specific example. I'm looking at the execution count of my cloud functions. And you can see it's kind of hard to see on this monitor, but there's two lines. There's this blue one up here, and there's this pink one down here. The blue one up top is labeled right here. We can tell it is the pink one is labeled right here. The other one's cut off. But the pink one is fulfill cool, and the blue one is request cool. So you request an image, it hits request cool. If I don't have an image for that, I go and I call fulfill cool, which actually goes, searches the internet, finds the image, and puts it into our cache. So we can tell by looking at this that fulfill cool gets called way less, which is exactly what we'd expect, because most of the time the image is going to be cached. So we can already see that things are performing as we'd expect here. But getting this type of insight is not that easy unless you can easily graph these things. So you can see how we could easily take this and say, all right, let's take our cron job and know that it's supposed to be invoked on average 1 time per day. And let's set up some alerts around it. And that's exactly what I did. So here's my daily cache cleaner job policy, which is looking at that exact metric I just set up. And it's just saying, hey, if this threshold is below 0.01 for greater than an hour, so if it goes over any window that's outside of that 24-hour window where it hasn't been invoked, do something. And in this case, I've set it up to text me. So every once in a while, something flickers on the internet. Sometimes it's a cloud outage, sometimes it's a DNS outage, sometimes it's something in my code. But these happen. And I get a text that says, hey, for some reason, whatever it is, that function failed to execute. So I'm not looking at this day to day. I just about never pull open this dashboard. But I can go through my day and be confident that if something goes wrong, I'm going to get told about it. And you can set these up for, like I said, a ton of things. So for example, I could set up a policy that said, if my cloud storage bucket dramatically increases in size, you should tell me about it. Because it either means there's a bunch of traffic that I should just be aware of, or I need to go turn up my cache cleaner to clean things out more aggressively. And so when that happens, when something like this happens where it's an issue that this number drops to 0 and then it eventually comes back, not only do I get a text message that says, hey, something went wrong, but about 45 minutes later or an hour later when the system heals and it reruns my cron job successfully, I get another text that says, hey, it's all good. So I do absolutely nothing to be involved with this. I've set this up and I just hang out and then I watch my phone and once in a while I get a text that's just like, yo, it's broken. And I'm like, okay, I don't care. And then a while later it says it's fixed. So this is the type of thing that it's not a big deal, right? Like you could probably figure out if something was down because someone would tell you. And this used to be how it was. Over the 4 years I've had this website, my friends use it and they'll message me angrily in the morning and be like, oh, JPEG Cool is down. I'll be like, I'll get to it eventually. But the important part is now I don't have to get my friends mad at me. They can be very confident that although we have no formal SLAs, I don't make my friends agree to those yet, that I will do a good job keeping this up. And if something goes down, I'll be able to tell them, yo, I know it's down. It'll probably come back. So the very last thing I want to talk about related to this whole thing, and again, there's kind of a theme of like side projects here because a lot of this relates to my own experiences building projects, consulting, doing small projects, things like that, is pricing and predicting pricing. This is a really short section, but it's super important. It relates to serverless again, but it's also just general advice. So first part, make use of pricing calculators. Every cloud provider has a pricing calculator. They're all pretty good. They all let you say, I'm going to use this many gigabytes and this many megahertz, and it'll tell you what it's going to cost. But the problem is, you will never know how many megahertz you're going to use. You're never going to know, unless you have really good planning, how much you're going to use. If only there was some tool that I just talked about that gave you all sorts of analytics about your application, about resource usage, that you could use to predict your pricing. That's Stackdriver. So if you go ahead and do that, you run your application, you keep an eye on it, you know what it's doing, it becomes super easy to predict your pricing and say, oh, Google Cloud's going to be cheaper for me, Azure is going to be cheaper, whatever. It gives you this insight that lets you use pricing calculators effectively, because realistically, having a calculator is only part of the problem. You really need those analytics that Stackdriver gives you. Part 2, again, super serverless specific. Not all apps are good for serverless. Not all apps are good for this type of setup. It's pretty rare that something, an app can't benefit from some piece of advice in here, but there are always exceptions. Nothing is meant as gospel, but things to think about. I said in the beginning, this entire talk is designed to just give you something that you think, oh, maybe that's neat, maybe that'll help me, but if something doesn't fit right, it doesn't fit right. And then the last thing about this entire thing, everything here, this entire talk is mostly about operational cost and maintenance cost. Writing code initially is generally very cheap, especially for side projects, but also in general, because you're very excited, you're enthusiastic, you do it quickly, you have big ideas, grand visions, and then it will always bite you 6 months or 6 years, or sometimes 60 years if you're the US Postal System. They still run on RISC OS as of like 2008. I don't know if anyone here knows what RISC OS is, but that's ridiculous. Anyway, sometimes these things stay and they have really, really long lifetimes, but you got to think about this. This is the operational cost, it's the maintenance cost, it's the cost of you having to wake up in the middle of the night because something went wrong, not knowing what went wrong, having to debug, having to remember what went wrong, having to remember how to deploy, having to remember, oh, this is or isn't covered by tests. There's all these things that are expensive, not only financially, but on you as a developer. So by doing a little bit of work up front, thinking about these things up front, you make your life way, way better. So that is the Cedar Camp philosophy of development. I know we went through a lot, so I think right here is an overview. We talked about clean, strong code, aka just use TypeScript. Systematic testing, unit testing, how to make that simple. We talked about deployment, rollback, continuous integration, and all those lovely things. We talked about environmental configs, initialization based on the project you're deployed to, not based on preset configuration files. We talked about monitoring with Stackdriver, and we talked about pricing using all that beautiful data from Stackdriver mixed with some other just general thoughts about the true cost of things. So here's all the links I shared. They vary. Some are official blog posts, some are external blog posts, some are docs, but there are all sorts of fun things to look at and think about. You leave this up until I see everyone's phones go down. I say that, and then one guy in the back is like, "Oh, me too." I swear, I'm not saying you sound like that, sir. I'm sure you have a great voice. Okay, cool. All right, cool. So that's the end of my talk. One final thing, if you like hearing about things like this, if you like seeing basketball shooting, AI robots, if you like seeing all sorts of ridiculous things, please follow me on Twitter. As you might suspect, my Twitter handle is AbeIsGreat. So you're more than welcome to email me there. You can also email me at my personal email, which is abeisgreat@abeisgreat.com. I wish that was a joke, but it's not. So I'm always happy to hear from people what you thought of this, if you have feedback, if you think I was too strong in my love for TypeScript. I'm happy to argue with you about that. So thank you very much, and have a great night.